Today we're going to review scientific notation from ninth grade. And basically scientific notation is what scientists use when we're dealing with numbers that are really, really big, like the size of a planet, or numbers that are really, really small, like the size of an atom. So this makes them very easily recognizable without having a whole bunch of digits all in a row, and it makes it easy to compare them. So first, we're going to go ahead and turn a regular number into scientific notation. And then we're going to go ahead and do it the other way, where we take a number that's already in scientific notation and we turn it back into a regular number. So here are the steps. The very first step is you're going to take the number and you're going to add a decimal point to turn it as a number that's between 1 and 9.9. So here's our first example. We have 348,100,000. And so when I look at this, I want to turn it into a number between 1 and 9.9. So I have to see where I would put that decimal point. And I know the place where I would put my decimal point is between my 3 and my 4, because that would make it 3.48. So I'm going to go ahead and place my decimal point there. And then I'm going to rewrite that number and drop all my zeros. So my second step is I'm simply going to write times 10. So mostly in algebra, we use a dot to mean multiplication. This is the one place where we continue to put the x for multiplication. So we're going to put times 10. Now we're going to go ahead and we're going to count the number of spaces where the decimal point currently is, in this case between the 3 and the 4, and where it naturally was in the standard number, which was after the zeros. And so I'm going to go ahead and count, and that of course is 5 places. So if we started with a number that was really, really small, like a decimal, then I'm going to make this a negative power of -5. If we started with a number that was really, really big, then we're going to make it a +5. And as you can tell, if we had this much money, we'd be very happy. It's a lot of money. And so that's going to be a positive power. And we're going to add that as an exponent on the 10. So it's a big number, and our answer in scientific notation is 3 48/100 times 10 to the 5th power. And that is our answer in scientific notation. Let's go ahead and take a look at this number. This is 0.000000027. And as you can tell, we're looking at a pretty small number here. We're going to go through these same 4 steps. First, we're going to take a look at it. We're going to make a number between 1 and 9.9. So we know we're going to put our decimal point between our 2 and our 7. Now we're going to rewrite that as a plain number, dropping off all the zeros. So that becomes 2.7. We're now going to write the x for our times and a 10. And now we're looking at the power. So we're going to count the number of spaces between the original decimal point and where the decimal point is now. And as you can see, that's 1, 2, 3, 4, 5, 6, 7, 8. And we take a look and we know we started with a really, really small number. If that was change and money, we wouldn't even have a penny. So we know that that is a small amount. And so we know that because it's a small number we started with, it's going to be a -8. So this number in scientific notation is 2 7/10 times 10 to the -8th power. So very simple. Now we're going to go ahead and convert it the other direction, where we're going to start in scientific notation. We're going to go through the steps to turn it back into a regular number. So our first step is to rewrite the number as you see it. So in this example, we have 3 94/100 times 10 to the -6. So we're simply going to rewrite 3.94. Second step is we're going to move the decimal point. Now, this is going to be important depending on the power. So if the power is a positive number, we're going to move the decimal point 6 in this case to the right. If it's a negative, we're going to move the decimal point 6 to the left. As you can see, it's a -6. So I'm going to go ahead and move it 6 spots to the left from where it currently is. So this is 1, 2, 3, 4, 5, 6. So I place my decimal point down. Now for every scoop, I'm going to fill in a 0 and I'm going to rewrite the number. So my new number is 0.000000394. And that is taking this number into scientific notation. So as you can see, when our power is a negative power, it doesn't make my answer negative. It simply makes my number very, very small. Okay, here's our example 4. I have 6 3/10 times 10 to the 4th power. So once again, I'm going to rewrite the number 6 3/10, and then I'm going to move the decimal point. I look at my power and it's a positive 4. So I'm going to move my decimal point 4 scoops to the right. So 1, 2, 3, 4. I'm going to fill in each scoop that is there with a 0. And I'm going to rewrite my number, dropping that original first decimal point. So in this case, my answer is 63,000. And that, ladies and gentlemen, is how to turn a number that is in scientific notation back to a standard number. Let's get some practice in our Desmos activity for the day.